So hello everyone, my name is Aditya Narayan Mishra and I'm making video on the topic voltage divider configuration. So let's just start. This is the equivalent circuit for the voltage divider configuration, and this part is called load resistance, and this part refers to voltage divider part. So we'll make the equivalent circuit for this. We need to find first RTH and VTH, and as we can see the current. Let me just make the circuit first. RC, this is VCC, this one is RE. This is in ground state. So this point is VCC, and to find VTH and RTH we need to make another equivalent circuit. So for this portion the equivalent circuit would look like, we need to sort the potential. This one is your R1, this is your R2, and there it goes. This gives us the region R equivalent. So R equivalent here, as we can clearly see, is the parallel resistance of R1 and R2, which is R1 parallel R2, which gives us R1 into R2 by R1 plus R2. Now to find out current in this equivalent circuit, we are going to add VCC that we had sorted earlier. The circuit will be same. All we need to do is add VCC here, R2, R1, and we need to find the current in this loop. So for current in this loop, we can see that R1 and R2 are in series. So for finding I, we can write I is equals to VCC by R1 plus R2, and we need to find voltage across R2 to find VTH. VTH is Thevenin's voltage to replace this voltage divider circuit, to replace this voltage divider part. So VTH will be equal to voltage across R2, which is equals to I into R2. I we have as VCC by R1 plus R2 into R2. So this will be our VTH. Now making the final equivalent circuit to find IC and IB. So the circuit would look like, final circuit. This is our VTH, this is our RTH. The current IB flows through it. There it goes. RC, IC, and going to VCC, IE, RE, and these is also, these both points are grounded. So in order to find IC and IB, we are going to apply KVL in this circuit. So we'll start from this point, VTH minus IB into RTH minus VDE minus, this point is VDE, minus IE RE, and we are here again, which is equals to 0. So by simplifying, we will get IB is equals to VTH minus VBE by RTH plus beta plus 1 RE. From where did we get beta plus 1 term? All you're going to do is replace IE by beta times IB. As we know, I is equals to beta times IB. So we'll get the IB from this expression. So in order to find IC, we're going to do beta times IB. As we know, IE and IC are nearly equal. So IC is also equal to beta times IB. So IC is finally equal to beta into VTH minus VBE upon RTH plus beta plus 1 RE. So we'll get IC and IB that we were finding out. And the final thing left is, what is VCE? VCE is this portion, this point is C, and this portion is VCE, voltage across point C and E. So to find VCE, we are going to apply open loop KVL from this point to this point, which will be equal to VCC minus IC RC minus VCE minus IE RE equal to 0. Since I is nearly equal to IC, we can write VCC minus IC, replace I by IC, RC plus RE minus VCE. So we'll get VCE as VCC minus IC RC plus RE. VCC is given to us, ICC will find out by this formula, and we'll get all the desired results. Thank you.